Welcome everyone to Fan Mathematics. Today we are come across to discuss the problem 1.3. So, what the problem 1.3 says, let's read out this problem very much carefully because most of the time students get wrong conclusion, wrong answer, or do some silly mistake because of the wrong reading of the question. So, let's basically start reading. Here it is defined that fx is a differentiable function defined for all positive real number such that this condition is satisfied. Now, if we carefully observe, this condition is given to evaluate this. Means how we need to evaluate? If we try to find any kind of function value, whatever it may be inside the x domain, whether it is e to the power k, whether it's anything, right? So from this kind of equation, you need to find the value of f of x. That's our main motivation to solve this problem. So let's see how to start this. So first, we write the equation which has been given. The equation is given as x f of x is equals to x plus integration from 1 to x f of t dt. Okay, this is the required equation given. Now, in such kind of equation, we need to use Leibniz rule of differentiation under integration. So we will try to differentiate both the side, differentiate both the sides with respect to x because the parameter is x itself from which we will find f of x. So if we observe this is two functions in the product form, so we can apply the product rule for differentiation. So first derivative of second derivative of first. So definition of x is we already know it is 1 itself, which is equals to definition of x, which is 1. And if we differentiate this, we need to apply Leibniz rule. Now, what is Leibniz rule? The differentiation of mu of x, phi of x, f of t dt is simply given by substitute the value of phi in the function, differentiate the function phi with respect to x, minus. Similarly manner, put the lower limit inside the function f of mu of x and differentiate the lower limit. That's the formula. So if we put x over in this, so we get f of x and definition of x is 1, right? If we put 1, we get f of 1 and definition of 1 with respect to x is 0 because it is a constant. Constant simply means independent of x. So therefore, it's will be 0. Now, if we see fx by, so therefore we obtain that f prime of x value comes out to be as 1 over x. So one can just simply find the value of fx by integration both the sides. If we integrate both the sides, we get integration f prime of x dx equal to integration 1 by x dx, right? So f prime of x derivative is f of x. 1 by x integration is ln mod x. ln mod x plus c, right? Now, here is one problem because we can't find the value of c, we can't find the value of fx. So what should we do? If you observe in this particular equation, just try to put x equal to 1. What I said, try to put x equals to 1. So if one person substitute x as 1, we get 1 dot f of 1 equals to 1 plus integration 1 to 1 f of t dt, which will be 0 because upper limit, lower limit same, the definite integral value is 0. So therefore we conclude that f of 1 is 1. So if we try to use over here, means f of 1 is equals to 1 using, what do you get with x equal to 1? That is f of 1 equal to ln mod 1 plus c. So what is ln mod 1? 0. F of 1, 1. So this is your c, right? Now if we put this c in this, so what we get? If we use c, we get f of x now as ln mod x plus 1, right? Now one can just try to do a manipulation. Like we can rewrite 1 as ln mod e, or you can simply write ln e. So ln m plus ln n gives you ln m into n mod x times of e, right? So this is your function f of x, right? Now next watch. If we try to understand what the question demand is, the question demand is about f of e to the power k. So f of e to the power k is ln mod e to the power k dot e. So e to the power k, e to the power 1 will be added. So ln e to the power k plus 1. Now we know the property that k plus 1 can be taken outside as a property of logarithm. So k plus 1 ln mod e when mod e is 1. So therefore we get f of e to the power k as k plus 1. That makes your question more and more easy, right? So if we just observe, now if you put value of f of e to the power k, so summation k equal to 1 to 10 k plus 1, right? So what is the summation of k? It is k plus 1 by 2, right? And it is moving from, wait a minute, we know that summation of n is n plus 1 by 2, so summation of k, here this is your n, so we put n plus 1 divided by 2 by the formula, right? And we are adding 1 up to how many times? 10 times. So 1 plus 1 up to 10 times will be 10. 2 5 is 10. So it will be 5 into 11 plus 10, which is 55 plus 10, that is 65, right? So I see the answer. I just stick it. I hope you get your stick it to your brain. So if there is any query, any single doubt about this problem, you can just comment in the comment section, or you can just contact me on the Telegram from my YouTube description links. You can just contact me anywhere. Thank you so much, everyone.